Okay, yeah, sounds good then.
Thank you.
Thank you. So thanks everyone for joining us today. We're from Animoca Brands, Mo and myself, and today we'll be presenting the first part of this series, of this three-part series on the introduction of blockchain and tokenomics. And we're very happy to be invited by the KACST Academy here to work alongside everyone to educate and share more about the vision of Web3 and what's building in innovative technologies these days. So on the agenda today, we'll go through in general what Web3 is, how we're going to take back the internet, and then run through some of the fundamentals behind what Bitcoin is, what is Ethereum, and also consensus mechanisms. This will be our first part, and then the next few sessions and future, we will go through in depth more of what the different features and architectures we talk about today look like. So an introduction to myself and Mo. My name is Jerry. I'm a senior tokenomics analyst at Animoca Brands. I've worked with the company for 2.5 years in the tokenomics team, mainly focusing on go-to-market strategy, understanding ecosystems and value accrual for the tokens, and also specializing in different governance systems. And with me today, we have Mo, or Mohamed Ezeldin, the head of tokenomics. Mo, if you'd like to say a few words.
Again, it's a great privilege to be here today and really share sort of our learnings and our experiences with the amazing group of technologists and builders here as well. This session will probably be the most technical session, at least for the second, third, and fourth part of the agenda. So if there are any questions, please do ask questions in the chat. And maybe at the end, if we have time, we can spend some of that time on a Q&A as well. But thank you in advance, everyone, for your attention.
Thank you.
Excellent. So, sorry, thank you, Jerry. So the first segment today is Web3. Again, many of us who may not be familiar with blockchain may not have heard of Web3 before. So we'll just go maybe into the evolution of the internet over time and why Web3 becomes super important. So over time, again, from the early 90s, when the internet became more accessible, we had what we called Web 1, which was a static or read-only. And then from 2005 onwards, with the rise of like social media sites such as Facebook, we had this notion of read and write, and we'll go into more detail. And then Web3 really from 2020 onwards, with the advancements in blockchain technology, allowed this concept of not just reading and writing, but also this concept of ownership. Next slide, please, Jerry. So from Web 1 to Web 2, before we dive into Web 3, it's always good to take a step back and see how we got here today. And because to understand what makes Web 3 special, we really need to understand what came before. We spoke about Web 1 very briefly, the read-only web, which was from the 90s to the early 2000s. And this was really the beginning of the internet, or at least for people interacting with the internet. Back then, websites, they were basically digital brochures, if you like. They were static pages with text and maybe a few images. You could visit a site, you can read what was there, but you couldn't really interact with it. You couldn't leave a comment, you couldn't upload a photo, you couldn't share your opinion. It was like reading a newspaper, but just online. It was a revolution in terms of information sharing, but users were passive. They had no voice and no control. Fast forward to Web 2, which is sort of from the early 2000s until today, and that this was the first paradigm shift we saw in the internet. And that's because you weren't just a reader, you could also write, comment, upload. We saw the rises of platforms such as YouTube, Facebook, TikTok, blogs, forums, Reddit, and so many more. And the web became a lot more social, collaborative, and interactive. And at this point, everyone could become a creator. The good part, what did we see in Web 2? Is that creativity exploded. We saw communities forming, we saw movements growing, people connected like never before. But as we'll see in the next slide, Web 2 also came with a price. And here are some of the challenges with Web 2. While it allowed for new content creators and being able to build an audience, It allowed you to drive engagement and help platforms grow through network effects. As a user or as a content creator, you'd only receive a small share of the value that you generated. And really the underlying platforms, they decide what that value is. And when I say what are these platforms, like we were saying on the previous slide, it's your Facebooks, your Instagrams, your Twitters, your X's, your YouTube, and so on. Because of decentralization around these platforms, you really could be banned or shadow banned or demonetized at any time without warning. And your reach really depended on an ever-changing algorithm that content creators and users alike had no control over. So these were some of the challenges on the user and creator side. Whereas on the big tech company side, they own all the infrastructure, the servers, the apps, all of our user data, and they decide who gets the visibility, who gets an inverted commas silence, if you like. They kept the majority of the revenue that the content that us posting on these sites would generate. They'd also use our data to monetize, often without our consent, or at least in the beginning when you join a new platform, you have these many pages of terms and conditions that no one reads. We all click accept, but what we don't realize is we're actually giving up all of the rights to our data and monetization of our data over to these big tech companies or these platforms. And they can change the rules at any time. So what are some of the solutions that or from the problem set that we've just discussed, there needed to be a newer paradigm shift. And really that's where Web3 comes in, or the internet of value. And Web3, the best way to think about it, we've spoken about reading and writing, but what it really allowed you to do because of blockchain technology, it allowed you to be an owner or a co-owner in an ecosystem, in a platform. And the rules are enforced by code, not by corporations. So again, a big mental shift from maybe the operating systems, or the mental operating system, shall I say, of today, to a newer way of thinking that we still haven't seen hit mainstream adoption. And again, the core idea behind this is instead of building your digital life on someone else's platform, you own your data, you own everything that's digitized around what you do fully. With Web3, like your wallet, and we'll get into wallets later on, it's what replaces your login. And that wallet belongs to you, not a company. It holds your money, it holds your identity, it's your membership and access pass, and it contains different forms of digital assets. And everything is portable and controlled by you. Now, why is this a big deal? Well, creators own their contents and get paid directly. Users can participate in governance because you become a co-owner, you have a say in the direction the platform is going in. Communities can run themselves through decentralized governance. And platforms don't own in inverted commas, the land, if you like. The network does. So we can start to see how Web3 really puts powers back in the hands of the user, where the user is no longer a consumer, but they're actually become an active participant within the ecosystem. And maybe one or two real life examples. I know that gaming is very big worldwide. As of today, when we play games, if you're playing FIFA or if you're playing Call of Duty or something like this, you don't own the skins, you don't own your in-game items. You can't really trade them outside of the game. Whereas with blockchain technology, and Web3, it really allows you to have ownership of your assets. So that means your in-game items that you're earning through playing, you can actually trade these and monetize on these outside of the game because you own that asset. And another aspect is maybe artists selling their art digitally. And every time the artist sold on, they have a royalty that goes back into the artist's account or into their wallet. So all of this is enforced on chain. So there are a couple of really nice examples to showcase how Web3 can really start to bring value back to all of us versus just the big corporation. And in short, Web3 really gives us that freedom and ownership that Web2 took away. Next slide, please, Jerry. Perfect. Now, this slide is as complicated as it may look. If you just break it down, we really look at the developer stack, and it's fine if this doesn't make sense now, but over the course of this session and the next two sessions, this will make a lot more sense. really the way we see it, and the language might be slightly different from what we're used to, is at the bottom we have our protocol layers. These are really our operating systems. If you like, Jerry later on will be going through Bitcoin and Ethereum, which we can see right there in the orange B and the gray sort of diamond. These are layer ones. These are your operating systems. You then have the infrastructure and the infrastructure layer. And what that allows is for multiple different things to happen. It can be our interoperable building blocks that allows our different layer ones or operating systems to communicate with one another. But they also allow for new applications to be built on top of the protocol layer as well. And within that, you can have identity, we can have decentralized compute, decentralized storage, we have different oracles, we have node infrastructure, and we spoke about wallets being your new way to sign in and store all of your information. All of these begin to fit in at the infrastructure layer, really allowing developers to start building the tooling for dApps, or dApps being decentralized applications to build on the protocol layer. And from different developer tools going up the hierarchy, we have different frameworks, we have some no-code solutions as well, being able to index what's happening on the blockchain, and so on and so forth. And then finally, it's that top layer, it's the application layer. And this is where we can start to see user-facing applications that really give people access to Web3 from a front end versus the technology layer, which again, Jerry's going to cover in a moment. I think onto the next slide, please. Perfect. So what does this mean, diving into more detail? Well, as we said, it's your protocol layer is your operating system, or your networking layer, so to speak, and it's the foundation where all Web3 applications arise from. It consists of your base blockchain architecture. Again, that could be a Bitcoin, could be Ethereum, could be Solana, which we're going into a few of those in more detail later on. The applications built on blockchain, what they truly allow for is a trustless and permissionless access. Again, when we use Facebook, we use Instagram, we use some of these existing social media platforms, the trust isn't on us as users, but it's on the platform. They're keeping our data safe, etc., which we know isn't necessarily the case. Some of the more important components here is that when we think about operating systems, most of these operating systems use something called an EVM, or an Ethereum virtual machine. And that just allows for easier connectivity between these different chains, but also the underlying programming language is the same. So developers can build in different ecosystems leveraging the same code. But then how can we interact between these different operating systems or layer ones? And you'll see me using these terms interchangeably. This is where we have bridges, but that's something we don't need to focus too much on today, because we'll be covering, I think, the second. Next slide, please, Jerry. Perfect. Now, our infrastructure layer. Again, this one way to think about this is our category primitives, and it sits on top of our protocol layer, or our operating system. It allows developers and users to read and write data to blockchain network. So without the infra layer, it would be very difficult to build on top of our layer ones, or on top of the protocol layer. It's dense, it's diverse, and really the best way to think about this is like with Lego bricks. Those familiar with Lego, what Web3 developers can use to construct and start building different applications based on the different infrastructure. And we went through some of the important components earlier on. Again, a lot of this exists today, but we're seeing it happen in a more decentralized fashion in terms of having decentralized compute or decentralized storage, not needing to store on AWS servers, for example, having decentralized storage, which can prevent single points of failures. Next slide, please, Jerry. Yeah. Perfect. Our application layer. Again, this is where things really begin coming to life, where users can start to interact. We've seen DeFi, or decentralized finance, where people are able to leverage their cryptocurrency to generate more revenue. We see something called DAOs, which is just decentralized governance, which allow people really leveraging the underlying blockchain technology and different forms of digital assets to be able you have a pool of resources, normally a pool of money, and then decide on how that money is spent. There's capital formation, and it allows for decentralized governance without the need for a third party to oversee that governance. So again, it's by the community for the community. We've seen it happen with metaverse and in gaming as well, and also NFTs. And NFTs can be used as in-game assets. They can be used to store reputation. There are many different use cases for NFTs, which we'll get into in the second session together. So finally, what does this look like? Or some useful dApps to know. And when we use, next slide, Jerry, sorry. And when we use the term dApp, again, I know a lot of this is still new, but over the next couple of sessions, this will make a lot more sense as we go deeper into it. When leveraging decentralized applications or dApps, just being able to buy and sell crypto in a permissionless way, so that we have platforms like Uniswap, which is the leading decentralized exchange on Ethereum. Radium is the equivalent on Solana, allows you to swap tokens directly from your wallets. Stake for being able to have different kinds of yield generation on your crypto assets. We have different applications there in terms of Lido or Rocket Pools, buying and selling NFTs. So you can think of it as a marketplace to be able to buy and sell different forms of digital assets. And then finally, liquidity provisioning for yield. So where these swaps are happening, you're able to provide that liquidity and earn yield on that. So we've sort of had a quick run through on the evolution of the internet from Web 1 to Web 2 to Web 3. We also spoke about some of these challenges within Web 3, the challenges within Web 2, how Web 3 solved this. And then we had a quick look at the tech stack, if you like, and why this tech stack is important. And on that note, I'll hand over to Jerry to do a deeper dive on Bitcoin. Thank you.
Thank you, Mo. Thanks, Mo, for that. So that was a lot of information that we just went through on the fundamentals of Web3 and the whole story of why we are where we are today. And from this part onward, we will go a bit on the history of how this technology came about and how it really, put distributed ledgers such as Bitcoin and Ethereum on the map. So the early days of blockchain began with Bitcoin, but before Bitcoin, right, digital money meant trusting a company, usually a bank, to manage your funds. So your bank account was just a number, a string of numbers stored on a private server, and that number could be altered, frozen, or erased, either by mistake or malicious intent by the administrator, which is very often humans. So if the system was hacked or an insider turned rogue, your money, your privacy, your information, it's all at risk. So in essence, you don't truly control your money, your assets. You just hope the institution that we trust wouldn't fail on you, right? And that institution could be banks or governments. And this kind of came into reality in 2008 when the global financial crisis shattered the trust of people, where people began to realize that maybe we need a different kind of system, ones in which we can trust and there's more transparency. So that's when Bitcoin emerged, and decentralized form of money without any banks, no middleman, and no single point of failure. And how Bitcoin worked was, instead of relying on one central ledger, every participant in the network, so that's all the user, keeps their own copy and transactions that are only confirmed when the entire network agrees. So this is known as a distributed ledger. So there are copies everywhere of the ledger of every transaction, so there can be no bad intention to be done. So with Bitcoin, anyone can create a wallet without permission, and balances are transparent and tamper-proof, and sending money is very easy, just clicking a few buttons. So Bitcoin is like email for money. It's very open, it's very transparent, and it's a peer-to-peer. And Bitcoin itself is a blockchain. Essentially, it's a public and digital notebook that everyone can read, but no one can secretly change. And this notebook records the full history of all Bitcoin transactions. So who sent how much, to who, and when, at what time, and how many Bitcoins or Satoshis are in each address its own and sent across the network. And how this works is when someone sends a Bitcoin, the transaction gets added to a new block, And adding a new block is like writing a new page in the notebook. And before the page becomes official, the whole network has to agree that everything written is correct. And this process of agreement is called the consensus mechanism. So one analogy we can use is, imagine a classroom notebook is passed from student to student and everyone has to write down something that's happened. But before adding the next page, the class has to vote to agree that the page is correct. And if someone tries to change an old page, everyone notices and votes against it. So the version with the most votes becomes the real history and is, etched in the blockchain. So in Bitcoin, it's not one person, one vote, and it's done using different rules. So it's like 1 unit of computing power equals 1 vote. And the system they use is called proof of work. So the more computing power you use, the more you contribute to the network, the more voting power you will have. So for someone to cheat in this network, you need to control more than 51% of all of Bitcoin's global computing power, which is very large and almost an impossible task. That's why this system works, and proof of work ensures no one can change a history without massive computing power, and that our transactions is tamper-proof, it's recorded, it's secured, and it's the consensus mechanism that allows the network to agree on what's true for us. So this slide is, the next few slides will be more technical on how Bitcoin works and why there's a hash function and how it protects blockchain integrity. So to run through this, a hash function is like a blender where you can throw any message in and it's then encrypted into a string of characters. So this is known as a digital fingerprint. And this fingerprint, we call it a hash. So no matter how big or small the input, the hash is always the same length. And with the same length means the same amount of storage data amount is required, and it can be predicted. So the properties of these hashes is that it's very fast, so information is calculated very quickly. It's deterministic, so we know the output is always in a singular form, and it's irreversible. So you can't turn the hash back into its original data format, right? It's very unpredictable and collision resistant. So small changes can cause large amounts of changes, impacts within the hash itself, and also no two different inputs can create the same hash. And the blockchain uses the hash function to ensure that there's integrity in the data that's stored, and each hash is connected to each other like a train, and that information gets longer and longer. So whenever a transaction goes through the hash of the block changes, which changes the next block's hash, if that makes sense. So this matters because everyone in the network is watching the latest block hash that's being published. So if someone tries to change the transaction from the past, then the fraud is instantly obvious. So the blockchain stays immutable and trustless, and where no one can alter the history via this hash function format. So this is visually how it would work, where each block contains a hash and the hash of the previous block, creating what we know as a blockchain. And each hash has data, its metadata, like engraved within it, which cannot be changed. So that contributes to the ledger itself. So how does a blockchain, a digital ledger, verify transactions and identities? So in a public system like Bitcoin or Ethereum, anyone can broadcast a transaction, like Jerry sent 1 Bitcoin to Mo. But how can the network be really sure that it really came from Jerry? Because I didn't log into any password and there's no account manager. So who is to prove that this transaction is valid? And this is where public and private keys come in. It's probably a common term that you might hear. And in this slide, we'll explain it to you. So every blockchain wallet has a private key, which is secret. And it's like a digital pen that you only control. And each blockchain wallet also has a public key, and this is shared, like your wallet address. It's visible to everybody. So when I, as Jerry, want to send Bitcoin, I have to sign a transaction with my private key. But everyone else will use my public key to verify that the signature is valid, which is my wallet address. Therefore, no one else can create the signature without my private key. So the analogy to explain the different types of keys is like, imagine I only have a special pen and I sign a letter and send it. So everyone that sees my signature knows that it's mine, but they can't copy it because they don't have my pen. So only my pen can give me the digital signature, which works like cryptography, which is how it verifies that the transaction is truly sent from the user. And of course, when the transaction happens on chain, it is then hashed into a message. And hashing this means that it's much faster to sign, and the private key is used to sign the hash. And that when the hash is sent across the network, then it acts as a message and a signature across, and all this information is verified using Bitcoin nodes, which then looks at the hash of the message, the signature itself, and also the public key. This is to check if the transaction is valid. So all this feeds into how sending things on a blockchain is much faster, and it's tamper-proof because it can't be changed. And this is very important because historically, this is the trust nature of the finance system that caused the financial crash and a lot of others in the past. So doing things on the blockchain, you don't need passwords, usernames, or other institutions or companies to verify you. It replaces trust with just pure maths. So this is what's very unique about the system, and it ensures authenticity, ownership, and security all via the blockchain, which is essentially a digital ledger that everyone can see. So the Bitcoin transaction process, you can see in this diagram. So someone would send a Bitcoin to a friend. The transactions are packaged into a block. The block is sent to the network of nodes, so everyone that owns some Bitcoin, and the nodes validate the transaction. The block is then chained onto previous blocks, so previous information, and Bitcoins is received, and the system goes again. So on this slide, we outline how wallets are created. Wallets are essential to participate in this digital ecosystem that we saw about, and digital signatures use a private key to prove ownership and identity on the blockchain. So the question is, where do these keys come from? And how do we create a wallet to use them? So a crypto wallet isn't a folder that holds your coins, but it's actually a key management system. So your crypto lives on the blockchain. So cryptos like Bitcoin, Ethereum, Solana, even other names like Dogecoin, Pepe, Shiba, those count as well. And they live in your wallet and they give you access. You have access to it through your private key. So your wallet address is like a blockchain identity, similar to an account number, and anyone can send tokens to this address. So you could send one to like jpeg.eth or 0x and the address and so on. So when you create a wallet in something like, you might commonly hear like MetaMask or Phantom, it's just clicking a button, but behind the scenes, a lot of complex cryptography is at work. So a random seed phrase is generated for you. The seed phrase is usually 12 or 24 word phrase that you have to remember, and this is your master backup. So if someone gets this 12 or 24 word mnemonic phrase, they can take your wallet. So that's very important. So when you see this, do not screenshot it. It's better to like write it down on paper and keep that paper singly somewhere. Don't upload it onto your cloud, because all this means that someone can get access and know the passwords to your master bank account, which is your digital wallet. And from the seed, a private key can be used to then sign transactions and also track the information that you're transferring, whether that's different types of tokens or different types of activity. So there are many different types of wallets though. So wallets can come in the form of software wallets where they're like apps you just install on the desktop. So they're like Exodus wallet or MetaMask desktop versions. But all these have some kind of risk as even though they give you a lot of control, desktop wallets could be hacked. Mobile wallets are better as they're more convenient and they're as secure as your phone is. And web wallets are fast and easy, but not ideal for holding large amounts of tokens. They're good for making activities quick and making sure you don't have all your eggs in one basket. On the other hand, we also have hardware wallets, which are known as ledger or trezors, and these are physical devices that keep your keys offline, which means they keep your crypto away from the risk of hackers, but it's much less convenient for everyday use. They're known as cold storage, which means there's only one single entry point, which only you and the device have access to. Other wallets are like custodial wallets, which are managed by companies like Coinbase or exchanges like Binance, KuCoin, OKX. They're really easy for beginners because you don't control your private keys. Everything can be signed on for you. And then there's also multi-sig wallets, which require multiple approvals for a singular transaction. So this is very good for teams, for treasuries, for companies, but more complex to sign up. So what generally happens is you might have a multi-sig wallet, let's say controlling 1 Bitcoin. And to authorize a transaction, there are 5 signers and you would need, let's say 3 or 4 out of the 5 to agree in order for that funds to be transacted across. So again, this is group for, managing funds for a group of people or for a company you have together. But it's much more problematic if you're just an individual trying to do things on chain. So what's very important for us to understand is which wallet type would you choose. So what I would recommend is if you're just starting out, maybe go for a custodial mobile wallet just to have a feel of what this digital ecosystem of Web3 feels like. And if you are very happy with the interactions you're using and the value you're accruing and you're storing more and more crypto, then increasing your security and getting a hardware wallet would be highly advisable to store your Bitcoin, your Ethereum, and other valuable assets. And if you're transacting very often, then having multiple mobile browser wallets might be more beneficial. So you don't put all your eggs in one basket and you can segregate your activities. So deciding on the wallet type is really about the trade-off between convenience and security, and also how much you're willing to risk. This is very important for us to understand because in the backdrop, it's all about security. Security for ourselves, for our assets that we hold. Because on the news, very often you would see hacks or people losing money or phishing scams from downloading the wrong Zoom link, or opening the wrong PDF email, and suddenly you lost some of your assets. So some of the security practices that we encourage is as follows. So don't share your private key or seed phrase with someone, not even if it's support or whichever admin or person that's helping you resolve any issues that you have. And don't back up your seed phrase online. Make sure it's offline, just write it down. Don't have any screenshots because someone can always get access and drain your funds that way. And it's always best to use a hardware wallet to keep large amounts of sums. And on the scam side, because you have to sign transaction, it's always good practice to double check and read what you're signing. There are tools that you can download, like Pocket Universe, which tells you in writing what you are signing, because very often when you're signing a transaction, it's a bunch of code, letters and numbers, together, and to most of us, it's just mumbo jumbo, but actually those has meaning behind. And now there are extensions you can download that translate to you what you're signing. For example, you're giving permissions to transfer 1 Bitcoin for 101,000 USDT. Do you agree to this? So that will be written out for you and it's safe. So always double check what you're signing and also verify the URLs you click. So there are a lot of fake sites that pretend to be Microsoft or pretend to be Twitter or might even pretend to be Uniswap that looks very similar. So it's very important to check that. And of course, enable 2FA for your custodial wallets. So very often when you sign up with exchanges, they open a wallet for you. You have 2FA, which connects to, let's say, Google or Microsoft Authenticator, and that increases security for you. And also, if you're trading a lot or interacting on chain, split your funds across multiple wallets. So again, don't have all your eggs in one basket. I think what's really important to understand is that in Web3, we are our own bank and we are responsible for our own assets and interactions. That's why it's called decentralization, as there's no middleman, right? There's no support, there's no way to find out your password, so the forget your password function is not available, and you have both your keys to protect your assets that you hold. Yeah. And if you go the custodial way, like with exchanges, then there might be an option there. However, there's the risk, like FTX, which is a very famous exchange that just went bust and disappeared because of fraud. And in the past, more historically, for Bitcoin was Mt. Gox. So these are the risks that custodial and non-custodial wallets could have, and it's very important for ourselves to understand what our risk appetite is. So the next section, I'll talk a bit about Ethereum, which came a couple years after Bitcoin. So here are some differences. So Bitcoin is like a calculator. It does one thing very well, which is sending money. But Ethereum is like a smartphone where you can build apps on it. So these apps are called smart contracts because these are programs that can run automatically on the blockchain. Therefore, it means you can set parameters, and when those parameters are hit, stuff can happen digitally and it can be enforced 24/7. So an analogy to maybe help us understand this a bit more is a smart contract is like a vending machine. So you put money in and the machine will check the input and you will get your snack or drink. And there's no humans involved. And smart contracts work in a very similar way. If conditions are met, the code is executed. But instead of receiving a snack or a drink, you're actually automating finance, you're automating ownership, you're automating governance, or even you can automate like legal contracts. So there are lots of things that can happen powered by smart contracts, which doesn't need us to be there 24/7, but it enables us to augment our lives and businesses for a 24/7 environment. So on the Ethereum, developers can build apps on the blockchain, not just with cryptocurrency, but their applications using logic that people can use. And when conditions are met without middlemen, with just the trust of math, things and transactions can happen. So this has helped transform industries like finance, art, we mentioned earlier on gaming and governance as well. And these tools are generally quite early, but the possibilities are very big. So we see the growth of stable coins these days, and stable coins are great because they help power decentralized finance, which is a whole new industry beyond traditional finance itself. And we have seen that ripple effects throughout different industries, different regulations changes, as well as different companies diversify their treasuries, apart from just stocks, equities, and treasuries. So some use cases, we've seen, there's DeFi, there's NFTs, and there's also DAOs. So on DeFi, it's like banking without a bank. You can swap tokens instantly, without going through your bank. You don't have to ask permission to stake to get a particular interest rate or to withdraw your funds early. You just have to agree to the parameters that you signed upon. You can lend money at your own will and earn most of the interest, unlike banks, which take a good chunk of that share. And you can borrow using your assets at a whim without waiting for 7 or 14 days for human approval. It's just done on chain and it's done peer to peer. It happens directly from your wallet through code without any paperwork. And that logic runs automatically on chain 24/7. It's open to anyone. You may not even have to KYC, and it's fully transparent and can be anonymous. So this is really innovative and revolutionary, and we've seen the finance industry go beyond this as well. Another segment is NFTs. So NFTs, you might hear this term a lot, non-fungible tokens, and you might, anchor them with JPEG. So Bored Ape Yacht Club, Good Vibes Club, Pudgy Penguins, Doodles. These are all famous ones. But essentially, NFTs are digital containers that can store anything. So it doesn't have to be a picture. It could store your right to a game item. You can store certificates. It can store access rights. And you can use that to own different types of art, music, to trade in-game items that you control, or to access different perks. And what's very unique is once you own an NFT, no one can delete or change it. You can sell it or transfer that right to someone else, and everyone can see who owns it. It's like turning digital things into assets you can control, and it's not something that a company can take away for you. And on the other hand, we also have DAOs. And DAOs are like internet communities with a shared wallet and built-in voting. So very often they use tokens that could be NFTs or fungible tokens like cryptocurrency itself to vote on how to, let's say, spend money. So give a grant to someone who's trying to grow IP for, let's say, ApeCoin or Pudgy Penguins. Grants to fund other projects, or vote on parameters that changes rules. So let's say there's revenue sharing in this system, and how much revenue share can everyone get? So examples of famous DAOs are like Jupiter DAO. So you can vote on protocol fees and revenue share for everyone that owns and stakes the token based on the revenue that's made. There's also ApeCoin DAO, which lets members make proposals and vote on how to fund and grow the IP to grow the business and brand awareness of Bored Ape Yacht Club. So essentially, there's no CEO, there's no manager, there's just code, votes, and a community with shared goals. And this is very important because they're not just ideas that already exist, but they're people all around the world 24/7 using these smart contracts, replacing middlemen, automating agreements, and creating new forms of ownership, finance, and community with all these tools. So I would say we're quite early to this, and the shift has just begun, and adoption has only been increasing every year. So a bit on our last section will be on consensus mechanisms. And very often you would hear proof of work and proof of stake use. So Bitcoin famously uses proof of work as its consensus mechanism, where miners solve complex cryptographic puzzles to validate transactions. And with more mining power, it means more computational power you have to solve the math problems to then be awarded Bitcoin. So therefore, in this system of proof of work, to attack the network, you would need to control 51% of the total computing power, which is ginormous for at least the Bitcoin network. That's why it's extremely secure and is trusted, and we've not seen the system hacked. On the other hand, we have proof of stake. So proof of stake is where validators will stake their crypto to participate in validation. So voting power is equivalent to how much crypto you have staked. And therefore, in the system, to attack the network, you need to have 51% of the total staked crypto. So proof of stake is commonly used by Ethereum and most other modern blockchains. And depending on how decentralized and distributed your token is, this proof of stake network can be very strong. So for example, Ethereum is very decentralized. Therefore, it is almost impossible to acquire 51% of a total stake network. However, other tokens with much less distribution, let's say it's a niche token and only 1,000 people are validators and control the network, then you would just need to control 501 of the total staked crypto within that circulation in order to influence the network. So these are the key differences behind the consensus mechanisms that we see and are most widely used today. So the visual of how it will work is in proof of work. The miners gather pending transactions and group them into a block. Then they try to find requirements that match each other to find a nonce, that they call it. And the first miner to succeed will then broadcast to the network that they've created the block to the network. And others miners will then verify that the block that created by that first miner is valid. If it is valid, then other miners accept the block and start mining on top of it, therefore gathering new transactions to merge again, and the whole cycle repeats. That's why in this system, due to its singular and chain format, transactions on Bitcoin are much slower in this sense. So when two miners find the same block at the same time, then the longest chain generally wins, because the network agrees to keep the chain with the most work. And this is unique because in this system, attacks require greater than 50%. The math needs to be checked and verified, but it can be done so by anyone. And it's almost impossible to rewrite the history because there's always another steady state out there with a more coherent picture of what's being worked on chain and the transactions. The downside of the system that there's very high energy usage and also the risk of centralization at the early start. But now, as Bitcoin is very decentralized and a lot of people hold it, that risk is now much less. So a couple of years later, there was the introduction of proof of stake, which was widely adopted by Ethereum and also other chains. And proof of stake is much more greener way to make consensus because it doesn't require much computation power. Because validators are chosen based on the stake, the number of tokens that they commit to the network, which means the more stake you have, the higher chance you are to win that proposal of a block. The current rule is that you would need to stake 32 ETH to get randomly selected to propose a block to become a validator to get verified and rewarded. And the way to punish bad actors is generally to slash. Other consensus mechanisms that we see out there are like proof of history, delegated proof of stake, proof of authority, practical Byzantine fault tolerance, and pure proof of stake. And these have been adopted by different types of blockchains to solve the blockchain trilemma. Generally, they want to be trusted, they want to be fast, and decentralized as well. So different consensus mechanisms provide different pros and cons, and therefore different chains are constructed differently. Yeah. So this comes to the end of our first part series. I believe we have shared quite in-depth amount of information, and we're open to any questions for the remainder of the time.